Hello YouTube. In this video, it's my 7th video on my module on logarithms, and in this one we're going to focus on the properties of natural logs. And it's not that they're any different than the properties of actual logs with any base, it's just we're focusing on the properties of logs that have specifically a base of e, so like ln. Okay, so remember right off the bat I'm going to go ahead and mention this. We say ln of x. This is the same thing as log base e of x. Okay, we're just saying specifically that our base is about 2.718-ish. Okay. That being said, we say the following is a list of some very standard properties of the natural logs, and these are worth memorizing. So when I say memorize them, I mean like memorize them. So anyways, of course the log of 1 always is 0, but the natural log of 1 is also 0. And the reason why is because a to the 0 is equal to 1. Well, I should be writing because e to the 0 equals 1 here. So that's a typo, but essentially what we're saying is this. If I said ln of 1 equals 0, I'm saying log base e of 1 equals 0, but that's because, hey, if you rewrite this in exponential notation, we're saying our base, e to the what power turns into 1? Well, e to the 0. You know, anything to the 0 power besides 0 itself turns into 1. So the next one here, log base e is 1. Why, or ln of e is 1. Why is this true? I should say e to the 1 equals e. But just to point this out on the right, we say ln of e. You know, you should just memorize this is 1. The reason why is because this is log base e of e is 1. And in other words, we're saying this. If we rewrite this in exponential notation, we say, well, our base, e, it's our base here, e to the what power equals itself. And so we say, of course, well, the answer is 1. Anything to the power of 1 would be itself, okay? The next two are very important to memorize. I'm going to skip down to number 4 first, but it basically says this. Hey, if the ln of x is equal to the ln of y, then x and y, they kind of be the same thing. So this is just the one-to-one property of equality. And this is definitely not specific to just logarithms and math. Okay, that's very true for many things. If two things are almost identical, then the parts that aren't identical are they are identical also. Number 3, this is very, very important. But recall that logarithmic things and exponential things undo each other. They are inverses of one another. So if I were to say ln of e to the x, I should just get x. In other words, the logarithm base e of the exponential thing base e should cancel out. The log and the exponential thing, those two things cancel out. But it has to be true that they have the same basis. So recall, I'm just writing here log base e of an exponential thing with the same base. The logarithmic thing with the base e and the exponential thing with the base e cancel out, and I'm left with just my exponent. Likewise, if I had an exponential thing to the power of a logarithmic thing, and they have the same bases here, you know, ln, keep in mind, has a base of e also. They cancel each other out, and I get left with just x. So using these properties, we'll just go ahead and take a look at what I've got down here. I say, well, let's use these properties to evaluate these. Give exact values to these expressions. Don't use a calculator. So if I said ln of e to the 1/3, I'm going to tell you right now, you get 1/3. 1/3, which property am I using here? I'm using the inverse property. Okay, so that would be, hey, if I took the ln of e to the power of something, I just get that power. Let's talk about why, though. We say the reason why is because I'm saying let's take log base e really of e to the power of 1/3. And remember, when you're doing a log, you're asking this question: what could I take this base to the power of to get this thing, the whole thing? So it's kind of a dumb question, but here's the question: what could I take e to the power of to get e to the 1/3? I think you'd have to take e to the 1/3 to get e to the 1/3, so we'd get 1/3. Okay. Another way to look at this is the logarithmic thing base e cancels out with the exponential thing base e if they have the same bases, and then you're just left with the exponent. Likewise, you know, this is another one where I'm using property number 3 up here, just the second form of the property number 3. I say I've got e to the power of, now I'm writing this out, not that I would ever do this in real life, I might just to emphasize my point, but we're saying I'm taking an exponential thing, e to the power of something, and the power happens to be a logarithmic thing, log base e. Okay, so an exponential thing to a logarithmic thing, if they have the same bases, these two things cancel out, and I'm left with just 8. That's all I have. Okay, and then last but not least, again, property number 3 here, we say ln of e. Well, ln of e, this is actually property number 2 also. Why is he saying property number 3, you might be thinking to yourself? Well, we say ln of e would be the same thing as log base e of e, which is the same thing as just taking the long road here. Log base e of e to the 1, this logarithmic thing base e cancels out with this exponential thing base e, and I'm left with 1. But another way to do this is just say, you know, like log base e of e is 1 because, well, e to the power of 1 equals e. Or just memorize ln of e is 1. It's an awesome thing to memorize. So if ln of e is 1, then really what I'm saying here is I get 1/6. And that's it. That's all I wanted. It's that simple. Okay, cheers.